Hi guys, how's it going? Hopefully you're doing well. I am going to do a video and kind of go over some notes from chapter 4. Some of it might be stuff we've talked about, but I'm still seeing some mistakes kind of out there and some confusion, so I just really want to make sure that I go over this one more time before we move on. So you should have already done a warm-up today, and that was supposed to go in your math notebook, and you were supposed to label it warm-up and that date. So go ahead and start a new page of notes, and go ahead and title it using reciprocals to divide fractions. Okay, using reciprocals to divide fractions. So first of all, let's make sure that we remember what a reciprocal is. So I think the best way to really, we've talked about a lot of these things, so I think at this point the best way is to really just show you an example. So the reciprocal of 1 over 3 is 3 over 1, or just 3, because we know it would be over 1. So a kind of simple way to say it is a flipped fraction. But remember, if I had 2, the reciprocal is 1 over 2, because we have to really remember there was a 1 down there that they just didn't put. So what's nice about dividing fractions, because normally when we have division, we feel maybe a little stressed out because it's division. We're not really dividing as our main step. Now there is a step that we're going to divide, but it's really your last step, and it's something you've been doing for a long time. So when we divide fractions, we're really using the reciprocal and then multiplying. So if I had 5 over 9 divided by 2 over 3, I really have, now on your paper, I want you to make this a second line of notes. So I want you to write it down here. But I really have a multiplication problem, and I make the reciprocal. So it's really 3 over 2. Okay, so you're flipping the second fraction, and then you're multiplying. And then when we multiply, we go straight across. So 5 times 3 is 15. 9 times 2 is 18. Okay, and then I would reduce. So, reducing. I am going to assign you this week just a little practice on reducing fractions. So please make sure that you do that. And then here's kind of a reminder how to reduce. I want to find a factor of both of these. So a number that's going into it, not a number bigger than it, a number smaller. Okay, so 3 goes into 15 and 3 goes into 18. So I'm going to divide both the top and the bottom by that same number. Okay, and if there isn't a same number to divide them both by, then that tells you you're done. There is no way to simplify this fraction. Okay, but if there is, you got to do it. And sometimes we see a really small number, we do this division, and then we see another number still can go in there, and you might have to do this process twice. Okay, so 15 divided by 3 is 5, 18 divided by 3 is 6. There isn't another number that goes into both, and so we can stop there. Okay? I think that I have seen you guys pretty good at multiplying fractions, so this is really just one more extension of multiplication. Now, when I said we're not really dividing, we're not dividing as our main step, but we're still potentially dividing here. Either dividing the top and the bottom by a GCF and getting a reduced fraction, or sometimes this fraction, just as an example, could be something like this, where you're just outright dividing 20 divided by 2. Okay, so sometimes you're going to see where it ends in this division problem and you need to finish out the problem. All right, let me show you one that I've been seeing some students struggle with a little bit. And that is when I have a single number divided by a fraction. Okay, so this first thing we need to do is put this in an A over B form. So we're going to make 8 over 1. As soon as you do that, you kind of see what's really going on. Now I have those two fractions that I've been practicing with. So I change this to a multiplication sign, and then I flip the second fraction. Now I get to erase because I'm on a whiteboard. For your work, I really expect it to work its way down and sometimes over when it makes sense. Okay, so now I work straight across. 8 times 3 is 24. 1 times 2 is 2. And this is what I was talking about. Now I actually do have a division problem. Okay, you can think of it as reducing, you can think of it as a division problem. Both really do get you the same answer. So 24 divided by 2 is 12. All right, let's do some word problems to really kind of tie this whole concept together. So keep all your notes on the same page, but I'm going to move on to some word problems. Now, when we're doing our math and we have word problems, sometimes we're like, okay, this is the division section. I bet I'm dividing on all these word problems. And we kind of function like that. And even though that makes sense, and even I've done that, like, okay, I know it's division, so I guess I'm going to divide. But we really need to look at the clues, the key words that tell us it's division. Because on a test, even at the end of this chapter, when we're on a test, it's not going to say, hey, here's the division section and here's the multiplication section. We're going to have to be able to make that distinction, okay? So let's look at some of these problems, and I want to explain to you how I know, other than it being on the division paper, that it really is division, okay? So Allison has half a cup of yogurt for making fruit parfaits. Each parfait requires 1/8 a cup of yogurt. How many parfaits can she make? Okay, so if she has half a cup and she knows each parfait requires 1/8 a cup, we really are asking ourselves, how many 1/8 fit in to half a cup? Okay, if we have this amount and we're fitting another amount into that first amount, or seeing how many we can separate it into, that's division. So I would just set this up, 1/2 divided by 1/8, which means it's really times 8 over 1. 1 times 8, 8. 2 times 1 is 2. This is a really ugly expo color. I think we're going to have to ditch this one after this problem. I'm looking at it. It's horrible. And then, like I said, I'm sorry, I get distracted. Like I said, this is now division, and that means 4 cups. And that makes sense. If I had half a cup, and I'm dividing that into 1/8 and 1/8 and 1/8 and 1/8, 4 of these give me this. Okay, so that was kind of how I told. Let's ditch this brown. That's how I could tell it was division. All right, so let's look at another one. So just listen for the keywords, some of the things I'm saying. How many tenths are there in 4/5? How many tenths are there in 4/5? Okay, so again, we're putting one value into the other value. So that means we're saying how many, so if I had 4/5, how many tenths can I put into 4/5? And you're going to notice the way that they have to word these problems with division in particular, and because division, the order matters, you might see the first term written last. How many pieces of candy, if I had 20 pieces, could I divide, or could I hand out to a class of 60? Okay, or no, 60 pieces of candy, pass out to a class of 20. I'm sorry, let me say that again. How many candy would each person get if I had 60 candies and I'm passing them out to 20 people? Okay, so it just is really going to depend on what I have and kind of what I'm dividing it by. I have 60, I'm dividing by 20. So the order of the problem sometimes gives us a clue. Other times we might have to even say it a different way. How many tenths go into 4/5? So this is going into that. That means this is being written second. So you really need to pay attention to that because it does get kind of confusing. And I can't tell you for every example it follows this pattern. It doesn't. There's lots of different ways I could say that. I could say, how many times could I put 1/10 into 4/5? I could say if I had 4/5, how many times does 1/10 go into it? The order matters in the math part, but you're going to have to really decipher in the problem because they might say this in the opposite order. They might say it in the other order. That's going to be something you're going to have to decide. What I sometimes tell my students is come up with just regular numbers and ask yourself what you would do with that. So how many 2s go into 10? Oh, okay, 10 divided by 2. And sometimes by doing that, it helps us see what's going on instead of being kind of stuck on the fraction part. Okay, so we'll keep practicing. It'll get better. So with this one, I'm multiplying and flipping. I'm not going to finish the problem because this isn't about coming up with the answers right now. It's really about deciphering when we're dividing. So let's talk about a couple more word problems. A pitcher contains 2/3 quart of water. If an equal amount of water is poured into each of 6 glasses, how much water will each glass contain? So words like equal amount, poured into each glass. Okay, so sometimes that word each, if we're doing something each day, would be multiplication, but we also know the opposite of that is division. So if we're kind of going back that other direction, we know it's division. Sometimes it just says in the problem, somebody wants to divide something by a certain amount. If you're sharing something with someone and everyone's getting an equal amount, that would tell us that we're dividing. What does everybody receive? We're sharing equally. Okay? These are all words that tell us that we are dividing. Okay? Hopefully that makes sense, and I will see you on the next video.